One of the unusual features of water is that it requires a lot of energy to get its temperature to change. And the way we can understand that is through this physical property known as heat capacity, which is how much heat is required to get a substance to change its temperature. And we're going to look at a specific type of heat capacity known as specific heat capacity. And this is the amount of heat required, we're going to use units of joules, to raise the temperature of a substance, of 1 gram of a substance by 1 degree Celsius. And liquid water has the highest specific heat capacity of any everyday substance. So what that means is we have to add a lot of energy to water to get its temperature to change. And just to give us some context, let's look at the difference between 1 gram of aluminum and 1 gram of water as we add heat to it in units of joules and consider its change in temperature. If I add 10 joules of energy to 1 gram of water, its temperature goes up by maybe about 2 degrees, whereas aluminum, it goes up about 10 degrees. If I look at 50 joules of heat energy added to water, its temperature goes up a little under 10 degrees, whereas that for aluminum is almost 50 degrees. So we know from our everyday life that when we add heat to a metal, its temperature increases really quickly, whereas if we're trying to boil water, it can take a tremendous amount of time. So we'll look at specific heat capacity in some more detail, but let's look right now at the relationship between heat and temperature in this phase change graph. When we look at water that is below 0 degrees Celsius, it's in its solid phase. And as we add heat to a sample of water in its solid phase, its temperature is going to go up until it gets to its melting point. At its melting point, even though we're adding heat, its temperature will not go up. And that's because the energy is being used to break the hydrogen bonds that are keeping those water molecules crystallized in the solid state. This energy here is known as latent heat. Once all the water is melted, then the water begins to increase its temperature as we continue to add heat until it gets to its boiling point. At its boiling point, its latent heat for vaporization, we can see, is huge. It takes a lot of heat to get water in the liquid phase to the gas phase. And that's because in the vapor phase, there is no hydrogen bonding. So to go from the liquid to the vapor phase, we've got to break all of those hydrogen bonds, and that's what all of this energy is. Now, the flat places on this graph are known as phase changes, going from down here solid to liquid and up here liquid to gas, and latent heat is the heat that's added to get that phase change to completely occur. However, these curves here where we're adding heat and seeing a change in temperature, that's specific heat capacity at work. And so there's a different specific heat capacity for ice than there is for liquid water than there is for steam.